Welcome to our second seminar of the week, which is part of the EBRLARC workshop on neural signal acquisition. In this course, students from Latin America are learning to build their own acquisition system using the Arduino environment, and will be starting to use the software Bonsai as a tool for performing experiments in neuroscience. The workshop, including these seminars, are taking place thanks to the generous support of the International Brain Research Organization, the Argentine Society of Neuroscience Research, and the Metropolitan Fund of the City of Buenos Aires. In today's talk, we have two excellent speakers that have developed immensely useful open source tools for neuroscience. Not only that, they have developed some of the tools that the students are learning in our course. Furthermore, the way that the directors of renowned international courses to which some of us, the organizers of this course, attended. So basically, we were truly inspired by them and now are trying to disseminate in our region what we have learned there, convinced that sharing of knowledge is a hallmark of open science. So it's a big pleasure for us to have Jakob Voigts and Gonçalo Lopes here. Thank you very much for accepting our invitation. I will first introduce the first speaker, Gonçalo Lopes, then I will introduce the second speaker, Jakob Voigts, and we will leave time for questions at the end of the seminar, but I believe that Gonçalo will make some like, we would prefer some interaction in between. We encourage the attendees to write down the questions in the chat or simply by raising your hand using the Zoom reactions tool. So we can give you space to use your microphone. I will turn to Spanish now. Si no se sienten cómodos haciendo las preguntas en español o escribiendo, perdón, si no se sienten cómodos haciendo las preguntas en inglés o escribiendo en inglés, pueden hacerlas en español y nosotros las podemos traducir. So I will turn back to English. Okay, so Gonçalo is a neuroscientist and software engineer who is fascinated by the intersection of intelligence, life, and computation. His early research focused on computer vision, visual reality, and the creation of new programming languages before switching to basic research in neuroscience. He completed his PhD with Adam Kampf and Joe Patton at the Champalimaud Center for the Unknown in Lisbon, studying how the motor cortex is responsible for robust control of movements in rodents facing unexpected situations. Gonçalo is extremely passionate about open source software and making technology more accessible to everyone. This has ultimately led him to develop the Bonsai programming language to help and inspire researchers everywhere to build their own tools and remove barriers to answering scientific questions. Gonçalo is now the director of NeuroGEARS, a London-based technology company dedicated to creating and sharing tools and knowledge so that scientists can better understand the tools of their research and realize their scientific imagination. So Gonçalo, thank you for being here. You can share your screen now.
Thank you so much for having me. I think it's a great initiative. It's great to see you guys taking what we share and basically paying it forward by organizing events like this. So I will share my screen now. And it is actually the whole main point of what the story I wanted to tell you today, which is about my own story for open source. And it's basically the same feeling, is the feeling of receiving something and paying it forward. So basically, the same, what I'm trying to share right now is basically a consequence of everything that I have received, also from the open source movement. So that's the basic, I think there's like one message to share, is that's the really only thing you need to be part of the open source community, is this motivation, I think, to receive something. And then instead of, because usually in our capitalist society, we tend to, if someone gives you something, you pay it back to that person, some money, right? In open source, it's not like that. Like you receive something and you don't actually need to pay something to that person. But what you should do is, in return, you pay the community back. So that's that's I think the main message. That's the only message. If you forget everything that I'm going to say and just keep that one message, that'll be it. Then the rest is I can share only my story, which is a story of serendipity, which means basically a lot of random luck and the opportunities that show up, and that I was lucky enough to be able to take them, a generosity of many people that towards me, and the chances that I got, and as I said, my attempt to give back that generosity and those opportunities and chances. Yeah, so I now, as Veronica was saying, I am the director of NeuroGEARS, and it's a company, but it's very interesting in my attempt to restructure capitalism in my own way, which is basically, that's why I say NeuroGEARS is a company and not a business, because a business is towards making you have to make a profit towards a good deal. And a company is more like if you go to the root of the word company, even in Spanish and Portuguese, it comes from compañía, comes from actually sharing the bread, compaño, compano. So it's the idea of a company originally at the root of the word is that you get people together to share the life's bread. So you kind of work together, you earn your bread together, and you share it. So that's also the motivation, the way I'm framing these old meanings to modern kind of ventures. So that's what NeuroGEARS is about in a nutshell. So as I was saying before we went live, that unfortunately didn't have that much time because of many reasons this week to put this together as well as I would have liked, but we can use this as whatever I put in here as a conversation starter. And this is why I asked Veronica to say at the beginning that if you have any questions at any moment, just throw them at me, and I'm happy to just pick up on what you guys want to know and just talk about that. So we can make the conversation as you wish. Otherwise, I'll just go. Okay, so this is an outline I put together because I was trying to pick the points I wanted to talk about. So my journey, this is my own personal journey, started in industry. So when my background is in computer science, in engineering, and even though I was always doing research because I was in a lab at my computer science department researching artificial intelligence. But even when I was in that lab, I immediately joined a startup in Lisbon. That was a very exciting place because in Portugal, where I'm from, I'm originally Portuguese, there was not that many opportunities to do the kind of cutting edge work I wanted to do as a computer scientist. I wanted to work with virtual reality, with augmented reality, computer vision, video games, and this was back in early 2000s. So it was about like 2005, 2006. And at the time, many of the current modern booms in Portugal had not happened yet around these areas. So the company where I was at initially, White Dreams, now I will show you some of the work I did there, was a great chance for people from my generation to get started if they were interested in these topics, robotics, like all of these kind of modern things. It was one of the places to be. And I was there, part of a research laboratory that we developed essentially tools, technologies for the rest of the company to then do work with. And what I learned from being there, I was there for 5 years, is that, and now it's even more so, and it was already true when I was there, but it's even more so now, that industry exploits a lot of open source work. So it's really like a lot, usually you see a lot of this kind of facing of a product or something that is doing something that is quite amazing. And I would bet that underneath, there's quite a lot of open source frameworks and libraries that are being used to power that work. And this was already true, as I said before, and now is even getting even more. And this is now due to my own motivation. I learned a lot. We were putting together a framework to do virtual reality, and And I was part of the team that was developing this framework from the ground up, from scratch. And we had to put it together, and it was a complicated framework. We had to integrate computer vision, physics simulators, computer graphics, sensors, and actuators. We were doing, I will show you what I was doing in just a moment. And I realized that we had to progress faster. We needed to use what was already out there. And because the company was small, it was a small startup in Portugal, we realized we could progress a lot faster if we used open source tools that were freely available. And that's another phase of open source that basically allows communities and countries that don't have the resources to pay these hugely expensive licenses for established softwares. It allowed them to actually work and get a starting point to do something quite interesting, even if you don't have the financial baggage of like a big company like Facebook, Google, Microsoft, whatever. It could still work. So I learned so much during that time, and that's where I started feeling immediately the need to create these opportunities for other people to share the work that we were doing. Unfortunately, at the time, there was, and this is another recurrent theme that I'll talk about during this talk, if I have time, is that sometimes even the politics of the situation you are in, it's actually not so easy, even if you want to do open source, to do it, because there's lots of pressure against it. At the time, it was even stronger, but now it still is there. And so when I moved on from the company, I decided, I found another side of open source that I wanted to do, which is when I moved from the company, because I was working in a company, I had a contract, the company was for profit. So technically, everything that I did as work for this company was their own property. I didn't own anything. So when I left the company, I basically had to leave behind all the tools that I had spent 5 years working on, and I never used them again. Basically, like it was all that work I will show you is not available anymore, because also the company moved on to other things, and it's all gone. So that was also the other thing that made me very sad, is I didn't want this to happen again, because we only have one life. I have limited time to do with my life, and I wanted to build things that would last, that at least I could use when I move on between places. So another way that I see personally open source is a way of owning your work, that if you do something, you make sure that it's available out there for you to reuse later on. And then, of course, meeting friends along the way is another of the great motivations of belonging to the open source community, is finding like-minded people that share these values. Okay, so to give you more of illustration of everything I was talking about. So this was the company I was working on during those 5 years, and this was the kind of experiences, experiments that we were running, essentially with the augmented reality technology. So this is technology where you can take the real world into the digital space of the computer and register it with some virtual simulation. So you can kind of be in a space with other elements that you can manipulate with your own body. And so this was back in 2000. This particular one was a prototype we showed at CES in 2010, where we basically were integrating a physics simulation that allowed us to not only create like little video games or simulations on a screen, but you yourself could place your body in the simulation. So you would come in, there's I don't know if you can see my mouse, but on the above the screen, there's basically a camera that is a 3D camera, which is the precursor to the Microsoft Kinect camera. That allows you to reconstruct for each pixel what is the distance to the camera that pixel is at. And we would use that information to create a kind of wall that would kind of push, like there's these little toys that they're like these metal push pins that you can push your hand through and leave a kind of shape. So you can think of the concept is exactly the same. As you approach the camera, you are pushing the world with your body. And we presented this as like this was we were making essentially a framework at the time. This was a demo of a framework that we were developing to make augmented reality very easy, very quick to use, where you could come, you could integrate not just cameras but other sensors. You could design very easily content and behaviors for the objects and do everything you wanted very quickly, very easily and quickly. And even though they presented it like this was a product, it's called Y-Vision, underneath there was a large technology stack. Let me see if I can move. See if got stuck in my own video. Let me see if I can look at this. Yes. So underneath, there was already a lot of technology, open source technologies that were powering even this demo. So some of them you might know, but so these are some libraries that we were using at the time in the framework. Opencv, you maybe have heard about it. It's a huge open source computer vision library. These two, so Ogre 3D is a graphics engine that people use to build video games, both either companies or indie game studios. Open Dynamics Engine is a physics engine, open source physics engine that was created by a neuroscientist, a theoretical neuroscientist many years ago. And it's an amazing tool, has been incorporated for decades in robotics, both simulators and actual robots. OpenAL is a standard from creative labs called Open Audio Library, like OpenGL. AR Toolkit was one of the first open source libraries for augmented reality, for detecting markers, and Arduino we were using a lot for incorporating sensors. And all of this, each of these pieces of software taught me so much about how to build and think about virtual reality, digital signal processing, and all the things that I'm now teaching and I taught at these courses, I learned by basically experimenting with these tools. So this is more of a, I will jump this slide now and we can maybe come back to it at the end of the talk, but I want to talk about challenges discussion. It's more a reminder for me to talk about these points, about licenses, ownership, copyright, and long-term maintenance of open source software, but I will jump this now. So then when I left the company, I then moved to do a PhD in neuroscience, and I realized while starting my experiments in neuroscience, we were in a lab that was interested in looking at behavior and specifically closed loop behavior, where the animal's actions in a box, so this is working with animals, the animal's actions in a box will affect and change what the environment that he is in, and we want to look at the brain in those conditions. And what I realized very quickly is that actually the needs we had for when building these boxes were almost exactly the same as what I had when we were building these interactive games at the company. We needed to use computer vision to analyze the behavior of the animal in real time. We wanted to create dynamic stimulus, like visual stimulus, like either lights or sounds that would change with the motion of the animal. And we needed to integrate a lot of sensors for measuring the activity in the brain. And in fact, it was pretty much the same problem. And so what I set out to do at the time, because I still had a lot of energy left at the beginning of my PhD, was, well, why don't we rethink and reimagine those ideas, but this time we make them fully open source. So basically, I took all the expertise I had from building that framework in the past and used them to make what is now Bonsai, which is this open source visual language for building scientific experiments. And yeah, the whole, this is a little thing that I think I will even leave for Jakob, because I saw that he has a slide about this. So I'll just briefly pass this ball to him. But basically, yeah, we need, neuroscience needs makers and hackers. We need tools that are accessible, forward-thinking, and versatile. I glimpsed that Jakob's slides. I know he has lots to say about this, so I'll jump this in the interest of time. And yeah, but the point of bonsai was to integrate, just a lot of devices to enable scientists to do lots of experiments. So it's not so much just focusing on a specific experiment, but is really giving you a language for combination. The same as a programming language like MATLAB or LabVIEW, if you have heard of these, do for you. And so we have done that, and over the last 10 years, so bonsai is almost 10 years, it will be next year, 10 years, we have put into it a lot of functionality that allows you to put together all kinds of different experiments. I will show you some examples of things that we did. So these are where we started. My advisor, Adam, his first, his PhD, his own PhD was in zebrafish, larval zebrafish. And so we started actually developing together, even during when he was teaching us about neuroscience, behavioral neuroscience. We started putting together some video tools for real-time tracking of zebrafish, multiple zebrafish. But then my own work was really with rodents, and we wanted to analyze the behavior, as I was saying, of animals moving in a box in detail. So we wanted to know not just where the animal position is, but also where the body parts are, like the paws hitting the steps, or where the nose is, where the tail, how the tail moves through an obstacle course, or things like that. And we wanted then to take this information and use it to change things in the environment of the animals. So now you can see the mapping between what I was showing you in the beginning of the person manipulating the visual environment, and what the rat is now doing in a box, which is basically we have a back projected screen. We want to show some elements, like in this case, it's just a dot of light, and the animals can touch that dot of light with their own bodies. And I can guarantee you that this is using exactly the same concepts we were using for that first framework, were applied to this experimental design. And we use it then for many other things. This is a virtual reality reconstruction of problems. So this, in neuroscience, when you do multi-channel recordings, you need usually to identify which cells you are recording from, or you want to separate the traces into different cells. And this is a visualization of an algorithm to separate each spike from a recording into different clusters and kind of visualize them in real time. I will try to wrap up. I don't know if we'll check the chat. I don't know if there's any questions at this moment, but basically the summary of all this is that there's been a lot of momentum behind bonsai that has really, for me, was very humbling, because even though I made it open source, I did not have any time during my PhD to advertise it at all, or do any push. There was actually no proper plan of like turning bonsai into this huge thing. That was not planned at all. I can tell you. Again, my main motivation was to make sure that I could rebuild these ideas that I had in my head, and the experience I had in my head, into software that I could use in the future whenever I needed. And that was my main motivation. So in a way, it was almost not entirely selfish, because I wanted people to use it, but I was concerned mostly that I need to be able to use this in the future. But then, just because it was freely available and anyone could use it, and it was somewhat easy to set up, it kind of grew in the institute in the Champalimau, where I was doing my PhD. Just by word of mouth, people started to ask questions about it and saying, okay, but what do you use to run your experiments? And I said, oh, I use bonsai. Well, what is bonsai? I have no idea. I never heard of this. Well, I'm making it. So it's, and then you kind of, and then they start seeing what you make. And then the question that follows is then, can I use it? And I said, yeah, of course, you can go here, and you can install it like this, and you can set it up like that, and you give some examples to people. And just by doing that, and by being available, basically by being there at the Institute because that's another thing, as I said, this generosity of is very important, because many times when you are doing your PhD, your experiments, putting together all your setups, it's a very hard thing to do. It's very lonesome. You're doing it for your own project, and you just need to get it done because you want to get to the science. That's usually what people describe. Now, coming from a software engineering industry, I found this to be a bit surprising, to be honest, because in industry, even though money is involved, which it is a lot, but there's actually a lot of culture of doing teamwork. Like, people don't imagine like building super complicated like softwares or products like alone, because it's just not going to work, or it's not productive. And I was actually quite surprised that the culture of like sharing and being available to answer questions was not so entrenched in at least in neuroscience. I found it to be not so entrenched as I thought it would be. And I was just doing it. So I was just, I mean, people would come knock on the door where I was sitting and ask, do you know how to solve this? And I would be just available. And now looking back and looking how far, because basically what happened to me from my point of view was, I was 5 years into my PhD. I was almost wrapping up. It was a very hard time for my life. And then once I step outside, I look around and I start realizing where bonsai has gone. And I had no idea how far it had spread. And it was basically all from those conversations. There was no other, I mean, the website, there was no website. Now there is a website, but there was no website. There was just an open source repository, which is not even on GitHub. Now it's on GitHub. It was on Bitbucket. And the only people who knew about it is really people that talk to me. There's just no other way that it could have spread beyond. But once I stepped out, I realized it was all the way around the world, because the people were using it in the west coast of the United States, and in Japan, and in China, and in whatever. And then I realized people started citing the publication, and it was really, I think that feeling of it's a different kind of feeling even from when, I mean, for me as an engineer also, because I like to make things and I like to see those things used. And to me is one of the most like rewarding things to see, I think, even more than having my publication cited, but it's just realizing the impact is a very direct impact, that someone on the other side of the world is using your software to realize what they want to do. And that's just very, very motivating to me personally. I realized that I am at my time. So this took a lot of, we can actually stop it here. I don't want, and because I know we will have discussions. I had more examples basically to show, but I think they bring the point across. And we had the series of questions that I will leave them for discussion because they're very prominent questions. These questions, I will leave them here for us to discuss in the panel later, because I think this, if we share, for people who share this vision, I think it's very clear, like what we need to do and what we should do, what we want to do. The question then becomes, where does it get hard? Because it will get hard. And I can share at least with you what I am trying to do. And creating this company NeuroGEARS is again a way of trying to do something different, because once you create a company, you actually, it's super hard. It requires a new level of sacrifices that I hadn't realized, especially if you then don't want to do it the normal way that people want to build companies for. But again, the same way that open source gave me a chance to do something different with my software, creating a company gave me a chance to do something different with how companies are run and make decisions about how how things should move forward. So so I can share, but I can share that with you in the discussion, and maybe we'll have more time to discuss that. I don't know. But yeah, I think I'll stop here. I'm sorry that this is not more streamlined, but it's.
That's perfect. Thank you very, very much for this excellent talk. So we move forward to the second speaker, who is Jakob Voigts. Jakob is currently a postdoc in Mark Harnet's lab at the MIT and will start as a lab head at Janelia in 2022. He studied math at the University of Heidelberg, where he got a taste for neuroscience and in the Sackman lab with Tansu Selikel, and subsequently did his PhD work with Chris Moore and Emery Brown at the MIT. In grad school, Jakob teamed up with Josh Siegel to build up open source data acquisition system, which became the start on Opencv. So thank you for being here. You can share the screen.
Thank you. Thanks for organizing this whole thing. And as Gonçalo said, this is like the foundation of everything. It's like people getting together and sharing, doing fun stuff together, and like making science creative and interactive. So thanks to you guys. I'll basically follow the same format as Gonçalo. I have a talk that I want to sort of skip through as quickly as I can and then have some time for discussions. Please interrupt me in the middle. And I'm going to start by giving a little bit of an overview of sort of what Gonçalo again alluded to, how we think at Opencv about the role of sort of technology in neuroscience and how we think this should be done. And then I'll give a super brief overview of some specific tools and look into the future a little bit. And then mostly looking forward to some fun questions and discussions afterwards. So let me share this guy. There we go. All right. So I hope you guys can see this. So the central question here is, why do we need open source tools? Like, what's the stuff we get from having open source tools? And I will say this is sort of in addition to all the points that Gonçalo already made. I'm going to talk more about the specifics of, like, if you're just a lab and you just want to get science done, let's just forget about all the other cool stuff that we all already agree on and say, okay, but like, what do we get out of it for driving science forward? And so the basic idea that occurred to us that's sort of obvious is that scientists and tools lead to insights. And then typically the insights are redistributed to other scientists, right? So this is the standard way people think about science is you write a paper, that paper gets published, or you put it on bioRxiv and then other people read it, or you talk at a conference to someone else and then they can ask better questions because of your results, and that drives human knowledge forward. But the tools typically end up straight in the trash because it's extremely hard to describe to someone how you did your experiment in a way that they can then use the same thing, because there's usually a lot of nitty-gritty. And so the idea here is that we want to take these tools and the like hard years-long work of actually getting an experiment working, which in neuroscience often is extremely tough because we're very much driven still by the advancement of tools, and get them back. And that's sort of the basic idea of Opencv, but equivalently of almost any other open source tool company. And so that is not a trivial thing to do. And I want to go through a couple specific aspects of this and why we think this is useful. So the first thing is that scientists are the ones that know the best tools, right? So they have the question, like Gonçalo building bonsai, there's a gazillion examples of someone having a specific problem and having to make a tool for the specific job. We need to redistribute those tools, I think, on a professional level. This is not something we can do sort of as a hobby, because making hardware, and this is specific to hardware, you can't just put it on a website and then someone else makes it, right? If you are a scientist and you build a gadget, if you then want to make that gadget available to everyone else, that pretty quickly becomes a full-time job, and now you're not a scientist anymore, you run a hardware company. So we need to take that burden off scientists a little bit and make it easier to distribute tools. If you do that, you get reuse. You get to use something that someone else had developed, which is intrinsically better than reinventing the wheel every time. And this is something I want to have a couple extra slides about this. we always like to reinvent the wheel. I do the same thing. I know all do the same thing. When you have a problem, you're like, why should I Google this? I can just do it myself. So there's another point here that reuse intrinsically is better. And then we get to the fun stuff, is that when you have open interfaces, you can be more creative. So this is, again, something Gonçalo already mentioned. If you can open the box and see what's inside, you often find that you can tweak things or understand things better, and actually that gets you to better science. So understanding and modifying the tools is extremely important. So, oh yeah, the last thing is that, and this is a slightly separate point, but one that I think is extremely important as well, is that once we have open source tools and we all share how things work, it becomes pretty obvious that not everyone should solve their own technical problems, because you're not an expert in everything. But we're currently in a system where if you're a scientist, you're expected to be an expert in everything. And we think that there's the need for people to just have the job in academia, as far as we can say job, because there's lots of funny things here. But I think people should have the ability to have the job of helping other people with specific technical problems. So let's go through this in a little bit more detail. So why can't we just distribute tools very easily? So on the left side, you see a design. This is the Cyclops LED driver that John Newman built. And this thing that we keep talking about when we encounter problems like this is the 80-20 rule, is that for the last 20% of progress, the design is already made. We just need to make it. That's actually 80% of the work, right? So if you have to design how to get to the product, you need to actually figure out what parts go on there. Right now, you can't even buy goddamn resistors online because we have a supply chain problem. But even before that, it wasn't that easy. You need to actually design the PCB. You need to make it sure that it's robust, then you turn it on, maybe it overheats. So now you need to redesign the PCB again. Now you need to make a user interface, document it so someone else can turn it on. Now, how do you order the parts so that you can just make it for your colleague, right? So there's a bunch of things you can only buy 1,000 of. So now, instead of just making one, you now have to make 10 or hundreds. Production, testing, then you need to ship it. You spend your whole day doing invoices, all that nonsense. So this is what we did at the beginning of Opencv when we thought, oh, great, we have a design. We can just make a couple and send it to friends. And we did that, but it was a full-time job. So that's not sustainable. And Josh and I, in the beginning, really took time off from our actual job being grad students to the generosity of our advisors that were basically fine with it. But not everyone can and should do that. It's a bad idea. So the next problem is, and this is something, again, that I did a lot and I'm still doing to some extent, is that if you have a problem, you like to solve it yourself and build it from scratch. So let's say I have some piece of software I want to write to track an animal, simple example, right? And I'm like, okay, I could install this other Python package and then I could learn how to use it or something. I can just build it from scratch and it works. And over time, that gets me somewhere. Instead, the blue line shows you over time what happens when I Google and find something else, right? In the beginning, I don't know how to install it. It's extremely boring. I don't like the way they programmed. They used a programming language I don't agree with. And I am really dissatisfied. But in the end, I get a result that works. But now I get a result that 2 people have looked at, not just me. So even though you could have solved the problem in the same amount of time, wasting the time and looking up how someone else did it gives you a better result because now someone else has already checked it. So we should always waste the time and get over ourselves and just use someone else's solution. Even if it's a MATLAB and we hate MATLAB, I don't care anymore. If someone else has a solution already, just contribute and make a common thing rather than everyone hacking their own little solution. And then sort of related, when you have open interfaces, you can be creative, right? So these days, most of our experiments are combining different things. So for instance, you might have, here's an Opencv system with a drive implant, but then you also have a B-pod because you do behavior. You might have a camera with some camera software. You're filming the animal at the same time. And really, these things all need to talk to each other. So when you build an experiment, you spend a lot of time stitching things together. And that becomes much easier when you have open interfaces and open source tools. And then finally, when you can open the box and understand what's in it, so here's the Opencv literal box, and you can download the actual schematic, you can understand what's in it, which is good for the people that made it, because you can find mistakes, or if there's a problem, you blow it up for some reason, we can look at how that happened and solve it together. But often also it allows you to modify things in some way. So the last point about scientific tools and open source that I want to make, where I think we all need to argue for a little bit of systemic change, for instance, how we spend our actual money from grants, is that when your car breaks, you don't usually try to fix it yourself, because that would be crazy. It's extreme waste of your time. You're not an expert on it. You don't have the tools. You don't have the expertise. But somehow, if a scientific instrument breaks, and it's something that is not just a complete off-the-shelf thing, everyone is like, oh yeah, just figure it out, right? This goes for extremely simple things and extremely complicated things, but it's almost always some waste of time, right? So you can make small mistakes, like for instance, you don't know exactly what AAV serotype to use in a specific application because your lab hasn't done it yet. And you're just like, okay, well, let's just inject a couple animals and see. You just wasted months of your time if maybe someone else in a different lab already knows it. And you're just supposed to know people, right? Like, this is easy for someone to say that's at a huge university with a bunch of other labs that are all helping each other. But for a lot of us, it's not that easy. Or if you're a junior person in lab, it's not that easy to convince a postdoc from a different lab. You use the wrong glue, your implant comes off. That's always my favorite example because that's something I deal with. But really anything from what laser to use to like optics, any example, small mistakes are extremely expensive in terms of time. And if there's a problem that costs you 2 months, then you can always, or you should always be able to take, let's say, 1 week of your salary or something like that and get someone else to help you. That's always a good deal because you save yourself the 2 months of messing around. And yet, in science, there's no money for this kind of thing in any grants. There's no ecosystem of people doing that. It could be interesting jobs for people that like to solve problems that are good at specific domain expertise. So we think there's an unmet need for this kind of thing where there's consulting. And in fact, like my 2-photon microscope was built, this is getting blurred out right now, by INSS, which is a company run by Bruno Pichler now, and he basically just goes around, designs custom 2-photon microscopes for people. You just don't buy an off the shelf, you buy his time, basically. So with that, I want to, and this is all stuff that I would love to talk about more afterwards, if you guys are interested. So let me give you a quick overview of the stuff that we've done at Opencv. And when I say we, it's really not me anymore, but a team of people that I'm going to try to attribute, but there's just too many people now that have done this amazing work. So the basic idea is that for Ephys, as most of you have hopefully seen by now, you have an electrode that goes into an amplifier where you essentially have a high input impedance that allows you to record from small electrodes. Then you digitize the data that goes into the PC, and then data files come out the other end. And sort of when we started in 2010, there were multiple different systems from different companies that were all not open source and extremely expensive. And then Reed at Intantech came out with this little chip that basically does everything that was on this picture. It amplifies, digitizes neural data, and it costs for 464 channels chip, which was significantly cheaper than one of those old school systems. And so then what we did is we put those chips in a little head stages, made a little box that connects to the computer, and then Josh wrote a software. And so these are the different components of an Opencv system as you've seen it now. And that to this day is a well-functioning data acquisition system for electrophysiology. There's a bunch of other cool things that I want to go through real quick. So this is the Opencv software, mostly driven by Josh Siegel, Aaron Cuevas Lopez, and Josh's team at the Allen are doing a crazy amount of work supporting and expanding the software. But by now, there's a lot of other people that have contributed to it. And similar to Bonsai, the strength of Opencv is that it's modular and that different people can contribute different plugins. So for instance, if you want to do, like there's a Python interface where you can stream data to Python. You can do triggered averages in real time if you're hunting for specific brain regions. These are all things that just started coming in. Similar to what Gonçalo was saying, that once the software was out there, it turns out that people just wanted to write software for it and put it out on the internet for other people. there's, as I said, there's a lot of plugins now that you can check out. But I think the sort of harder thing to accomplish in the open source space that I think we discovered sort of the hard way is making hardware, because of all these tricky bits of like actually getting things into people's hands. So here's a couple examples of hardware. So this is something that Philippe Carvalho at OEPS, that does all the production and distribution of tools for Opencv now, has come up with. So this is a head stage that's the same as the traditional head stages that we had before here, but it's much smaller and lower profile, so that animals can behave more easily, which makes a surprising difference. This is John Newman's Cyclops LED driver, which is just an extremely cool piece of hardware because of its speed and precision. These are the drive implants that I made once in my PhD, and in my postdoc I sort of wanted more punishment and made another one. So these are very small tetrode implants that you can get pretty good data from mice with. And then, because it's open source, really cool stuff happens. So here Arne Meyer and his friends stuck a camera onto one of those drives, which allows them to track the pupil position as mice roam around, which allows you to study retinotopic inputs in a mouse while it's running around, which surprised maybe to some. I think you could have seen it coming. They're different from a head-fixed mouse, so behavior is important, which is one of those things that I think more neuroscientists are realizing now. So cool things happen when you open interfaces and you allow people to mess with things. And Opencv is now also used for neuropixels. So this is Josh's project at the Allen Institute, is to use these neuropixels probes that have been developed by a huge consortium. And he and his team are adapting the Opencv software to work with neuropixels and make them practically useful through good visualizations. So this is one of those things that took even us a while to appreciate, is that it's one thing to get good data into your computer, but if you can't look at it and the visualization isn't good, then your experiment is going to suck, because you don't notice if you have noise, if things aren't right. So a lot of the work in Opencv and electrophysiology is having a good oscilloscope, having a good way to actually look at your data while you're doing the experiment, and really being in there sort of with your eyes. So they spend a lot of time on that, and that's really cool. By now, I already said there's a lot of users and developers, so the list has grown pretty significantly. And the important thing is that these are not just users, these are all people that are contributing by simple things like finding bugs, but also just contributing code. And then last but not least, we're involved in education and outreach initiatives, which is something that there's not enough of, in my opinion. So I'm extremely happy about your initiative, but generally there is no better way, in my opinion, to get people to another level with some specific skills that they don't have yet than just getting together for a week and really getting your hands dirty with tools. And that's another thing that's enabled with open source tools like Bonsai, like Opencv, like all these others, is to break down the barriers to access, right? We can now show up at tents with full Ephys systems and not do a toy experiment. We can do a real experiment. Or you cannot, you don't have to make a little toy tracker or something. You can do a real VR system with a tracker with Bonsai and really understands how it works. And then finally, funding is very important, because as we talked about, especially with hardware, you do need people that need health insurance and rent, and they need to save for retirement and have a family, that just put things in boxes and send them out, right? That's an absolutely crucial aspect of it. So Opencv and OEPS in Lisbon are funded through sales of products. We have a Brain Initiative grant that Josh got at the Allen for supporting the software. And we're also applying for other grants for Opencv. But I think the important thing here is that it's not quite enough to just be altruistic and share your intellectual property. Once we get to the hardware stage, but I would argue also to the software stage, at some point it is useful to have professionals take some of these roles. And for that, not just we, but the funding agencies should put some money towards these things. And that is starting to happen. This is not, this is a much better situation than we had, I would say, 10 years ago with the BRAIN initiative, at least in the US, recognizing this kind of thing. But I think it's important to point out that at the end of the day, we also do need to think about money and some professional aspects of it. So looking forward real quick, neuroscience is becoming more integrated, as we've already seen. So you have all kinds of different ways of doing experiments, tetrode implants. In the middle, you have Daniel Aironi's Miniscope project. There's obviously a lot of people working on Miniscopes now, neuropixels, behavior. And what we're working on now is to bring these things all together. And so this is going to be a tiny overview over the Onyx system, which is really driven by John Newman, with Aaron Cuevas-Lopez pitching in a lot now, Jack Zhang, also one of the developers. And the point of the Onyx system is to allow things like what you see here, where you have a head stage with a crazy amount of things on it. So for instance, 3D tracking, LED drivers, accelerometers, what have you. We put a lot of stuff on this little head stage, and we squeeze all that data through a tiny, tiny coax cable. And there's a bunch of magic that happens behind the scenes that allow you to go from a regular cable on the left side. This is the thinnest one that exists right now for the Intel Opencv systems, to the Onyx cable on the right side, which is a 0.3 millimeter stick. So it's like a piece of like dental floss or something. And that allows you, see the picture, that allows us to do some really cool behavior, because now to the mouse it is as if nothing is on there. And this thing transmits data and power at the same time. We have an acquisition system that you can plug all these little signals in for I/O and synchronization. And then you can do cool shit like this. So here you have a mouse that we're recording from. Let me run this again. And you see here a commutator that stops this thing from twisting, but the commutator magically knows which way the mouse is headed, even though it's not sensing any torque. And we do that by just sticking a compass on the mouse. And because it's a digital one-wire interface, you can just add the compass with no problem. So this is basically the foundational accomplishment of Josh and Aaron, is to have that interface that allows us to just put arbitrary data through there. And then once you have that, these tricks become easier. And we can also, because the tether is so little, run mice in extremely large arenas. And they do stuff like jump around. They're very happy. So we think that this is particularly important if we want to take neuroscience and get it closer to behavior again, like the example that Gonçalo showed with the rat chasing the dots. The rat wouldn't do that if it had half a toaster stuck to its head, but that's kind of what we're doing to animals right now. So this is, I think, a very important step in the right direction. The system is also extremely fast. So here you see a closed loop latency plot. And we're sort of faster than a spike right now. So you could record a spike and then react to it sort of before the spike is over if you had the right software for it. And then we have a problem with the system that all the data comes in sort of asynchronously, because when you do an experiment like that, you have 3D tracking, Ephys, audio, video, whatever, these things don't come in a simple time raster, and they're not typically aligned. So the Opencv software cannot handle it. We knew of no software that could handle it. So we were really unhappy. And then we realized, oh, wait, there's this guy Gonçalo that built this bonsai software that is exactly built for this kind of thing. So now we're using bonsai for any new Opencv Onyx developments to at all make this possible. And what this gets us to is that we can now take all these different experimental modalities and stick them all together and combine them using bonsai sort of as a glue. And this also makes it extremely easy to add new things, because you don't have to reinvent the wheel. You just need to get some digital data out of something, and then everything else works already. And this means that you can now interact with all kinds of pieces of software here on the left side, including also behavior control. But it also means that the output data now can be more standardized. So you can use neurodata without borders, for instance, or really any other format. But you have a standardized language to talk across labs and experiments. So neurodata without borders is important because it has a lot of institutional buy-in. And then I also wanted to highlight the Dandy Archive, which is an NIH initiative for storing data online and sharing it, and also making data processing pipelines online interoperable. So the idea is, for instance, that you could run an experiment, and while you're running it, the data is being uploaded to some cloud. It's not necessarily shared with the world yet. You can embargo it if you want. That's all fine. But then you just press a button and some spike sorting is run on it. So by putting all of this together, I think we can make neuroscience truly interoperable on all levels, which is not just good for replicability and not wasting effort. It also makes each individual lab more creative because you can just benefit immediately from other people's development. So then these are a very small subset of the contributors to all these projects. So thanks everyone for making this possible. Yeah, how you can keep up to date with Opencv on Twitter. Yeah, with that, I think we can go to chit-chatting. Thanks, everyone.
Okay, so, Jakob, thank you very much for this great talk. I remind people that you can write the questions down in the chat or just raise your hand. We have some hands up here. Clara McCarthy, which is one of our students.
Oh, sorry, I was just clapping.
Okay, sorry, my mistake. So, does anybody want to ask? Jocelyn, another student.
Hi, thanks. There were like wonderful talks. It really motivated me like, that's good. So I got a question for Jakob. You show us a camera. You can see the pupil dilatation. So I was wondering if that with the camera you also can look for other movements or things in their face, in the face of the mice, like the things for, you know, like when they're active sensing with the.
Oh yeah.
Yeah, you know what I mean. Yes.
Yeah, so I did whisker tracking. Sort of that was the first neuroscience drug I took was doing whisker tracking, and then I got sidetracked, and now all I do is neuroscience. Yeah, absolutely. This is actually one of the things we're thinking about doing maybe in the future is integrate cameras that are a little bit more forward-looking and allow you to do whisker tracking. I would absolutely love to do that. For whisker tracking, which I think is one of the things that we'll realize is extremely important as we go to freely behaving animals, because they're not extremely visual, right? They can do visual stuff, but they like to use their whiskers. So I think once everyone has access to just freely behaving mouse stuff, they'll all be like, oh, wait a second, we have to do olfaction and whisking again. The challenges with that are that whiskers are pretty fast. In my experience, if you really want to do whisker tracking, you want 300 hertz, which the cameras that Arne put on the drive cannot do. And we're thinking about ways to solve that. So the technology that John, Aaron, Jack, and others build, in theory, might be capable of doing that, but that's not straightforward. The simpler way, if you're just interested in a motor pattern, would be to do an EMG. So that's a hard surgery, but it's an easy signal to record. So there are studies, sort of old school ones, where you take tiny wires and you put them under the whisker pad, under the skin, so it doesn't bother the animal, as far as we can tell, if you do a very thin wire, and then you can do EMG. But that's a little bit trickier surgery-wise, and you don't get the whisker contacts with the environment, which is what I think you would likely be interested in.
Yes, and I was wondering also if they do stuff like for hearing, you know, for moving the ears. But I think it would be easier. Oh, I thought for the position could be like even more.
The problem with the whiskers is that they're extremely thin, so you need a very nice camera to see them, and they move very fast, so you need extremely high frame rates. And those two things are sort of fighting with each other, because to see small things and get good SNR with low light, you need long exposure times. But because they move so fast, you cannot have long exposure times. So the whisker tracking is extremely tough.
Thanks.
Okay, we have one question in the chat from Federico Vasque, another student from the course. He says, amazing talks. For Gonçalo, you said that open source tools are widely used in the industry for commercial products. Are these tools properly given credit in these cases?
Yeah, thanks, Federico. That's a great question, and it hinges a bit on a discussion I wanted to have, or I thought we could have. For software that is shared under open source license, they do require like attribution. So you have to give, there has to be somewhere in your software, where either the installer or somewhere in the interface where you say, we are using this and this and this and that. What is happening is then, what then can happen is you can get various effects, because then you will have somewhere where you will say this and this and that is used, but that can be an extremely long list, and you can get dilution effects where basically you have, I don't know, like these days you could pick any kind of commercially facing piece of software, and somewhere in there, in some README file or some, you will have a list of like 100 software packages you're using. But the thing is, you as a consumer will usually not even see, sometimes they even put it in the license agreements, like, you know, these huge end user license agreements that no one reads, that have like 100 pages. But they will have, if you scroll through to the end, they will have the attributions to the softwares that they are using. So technically they are fulfilling the obligations of the license, but they get diluted. However, I'm still even more harsh, which is even if they made it more prominent in the software, I still think it goes back a bit to what Jakob was saying, and to the idea that I was trying to say of the paying it forward. Which is the point. Credit assignment is good, but the thing is, in open source, now I'm going to talk specifically about software, where you are giving the tool for free. Just the credit assignment per se is not going to necessarily give you what the developer wants out of the project, because as Jakob was saying, in terms of science, if you're a scientific open source developer, at least now it's getting better, because now you can get methods papers that you can get grants that support development of open source tools, but it's still kind of not as big of an impact as like getting a first authorship in like a big science publication. And so just getting a credit from someone else, even as it's not going to necessarily give you more time or more funding to work on the product. And these companies, even if they do acknowledge the components, sometimes they don't contribute back to it, either by making pull requests or by making financial contributions. So even though they technically are like fulfilling the requirements of the license, if you can get even further, like if you go to like very cheap hardware products made from like in a large scale in China, for example, they will even comply with very harsh open source licenses that they force you to release everything open source, and they will happily do that, because in the end they don't care, because they're not including, the consumers are not part of that discussion. It's just, for them, it's just some paperwork that they have to fulfill, and they're still making tons of money by using. So it's a kind of more nuanced discussion at this point. I think it's a great point, but it's really tricky how to measure this. Yeah.
Great. We have one hand raised. Natalia Soldi.
Hello. Thank you, Gonçalo and Jakob, for your talks. I don't have a question itself, but I will make a comment, and maybe you can tell me what you think. And also like things that I see and personal problems maybe. The thing with open source, sorry, Gonçalo, I never tried bonsai, but I tried another things. I have to track animals, and the thing is that when I try to use like a program, I face the thing that I have to have programming skills that I didn't. So when I tried to use them, I couldn't, because I was like really bad at programming. Now I am learning, but that's a thing that I see that maybe people can face that problem, and I don't know how to. Yes, I have to learn how to program. So that was the solution maybe for me. But and another comment, maybe that people have to face when they like are starting the PhD is that you enter a lab and they say, well, this is the technique that you have to use, or here you have, and then well, you see this Opencv, this drive, very beautiful, but it's like you in the lab they use another thing, so you have to face also that if you want to change that thing, you have to like a big building, you have to throw it down and try another thing. So that's maybe also why people or labs tend to fall in pay license or something like that. So that's two problems I see. What do you think?
So, Jacob, maybe we can tag team for this one. You can take over the second one. I can answer the first one.
Yep.
So the regarding your comment, so what you just said about the barrier to entry in software is one of my personal and professional pet peeves about software development, is that it's absurdly and unnecessarily hard to enter and start programming. And this, in fact, my argument has nothing to do with the actual programming languages themselves, but it's more like the tooling ecosystem that is extremely hard. It's harder to set up things than it needs to be. And to give you an example of how important that is. So I started programming when I was very young. But the reason I started programming is my father bought one of these old Spectrum computers. And what was special about the Spectrum computer is you would turn it on and you would be in a programming environment and you could immediately start coding. And there was none of this like setting up, install things, and maybe this, how do I even get this to work? Like what does it mean to compile something? That was just completely removed. And you just thought about the pure logic of the program. And that is something that is very, very dear to me. And I tried, that's actually a very strong kind of motivation for bonsai, was to remove that barrier. That I tried to the best of my ability to basically, you install bonsai and you start programming. It takes care of all the dependencies for you. It's self-contained, and you can start just putting the modules together, and you will get something functional very, very quickly. And for me, that experience I had on the Spectrum, which was my entry point into programming, is something I'm trying to give people as well with bonsai. And I know you said you didn't try it. You should. I would be curious about your feedback if you do try it, and you see some of the videos. I at least that was something. I'm not saying I got it perfectly. There's lots to improve on this direction, but it is something that I care about quite deeply. And it is completely true what you said. Like that, it's not. I do think that people should all learn how to program, but my argument is it's actually made harder than it needs to be right now. I don't think it's because of people are not capable or whatever. This is all bullshit. It's you are perfectly capable of doing everything you need. Okay, but I'll leave Jacob to answer the second.
Yeah, no,
Sorry, maybe a comment. Like I think like new generations are coming with more skills, programming skills, but well, maybe we that are like older or something like that, people like undergraduates.
But even it's a good point. It's true, but even then, I interface a lot with all kinds of people and all ages of programmers, and even then in the newer generations, while they are fundamentally familiar with lots of different stacks of technology, but they still get stuck in their niches. And when they try to jump and do something that is not familiar to them, then they will also feel stuck. And this is something I have seen even in younger generation programmers. So it's a bit tricky. This part is actually quite sensitive topic of like, how do you set up an environment for you to start coding? It's people don't realize this, but that's actually one of the hardest in this 80-20 rule that Jacob is saying. I'd say like setting up your environment is almost like 80% of the effort to start programming, and the rest is much easier.
Yeah, no, it's crazy. I mean, I am often in a situation these days when I set up something new, I need to install some new Python package, and that I'm more afraid of than actually the programming, because it might break my environment and I don't know what to do. Like so many different ways of doing things. But I think that part of the solution could be, and this is a little bit in contrast to what we said before, and this is how I learn things often, is I look at examples that are very close to my application. So in your case, it would be if someone had already made a bonsai workflow that tracks an animal and you just have to install it, it works. then you take that apart because you already care about the problem, and then you can like mess with it and see. This is not quite the same as understanding it fundamentally. So some people think it's dirty to do that because then you don't really learn how to build things. But often, like, I mean, we're all in situations where like, oh dear, we have the animal implanted, it needs to run, we need to track it. I can't learn something new. I just need something that works, right? So I think there's a real need for, and I say us at Opencv as a community, but like all of us really, to make more example workflows and share that kind of stuff in a way that, as Gonçalo alluded to, you can just put somewhere and it works. And Bonsai is a great environment for that because you can just share an example workflow that all the dependencies will be taken care of. Obviously, Python is great for that because you, as much as I hate doing it, you can install the dependencies, right? And there's technology for that. So I think starting with examples is a good way, and just asking around for appropriate examples and then deconstructing them. As for building actual rigs and what you alluded to, how it's tough to get started with building a new experiment, in my experience, there is really no way around going to a summer school or actually in person seeing someone else do it to learn how it's done. We're trying to make documentation better, but there's so many little things that you need to actually see in person, partially because they're tricky and you need to see in person how it works and get feedback. But more importantly, there's a bunch of things that you and I, if we haven't done it yet, think are complicated. But then we see someone else and like, oh, that's actually not a problem. I thought that was a problem. That's not a problem. This is the different thing that I need to worry about, right? We imagine things being extremely complicated. And that's the kind of thing you cannot put in a documentation because you don't trust the documentation. You really need another human to tell you, you know how to do this. That thing, be careful with. This, you know how to do already. And so I think we need more hands-on summer schools. I mean, the Miniscope team has done a great job with their workshops. We're starting to do something like that with drive implants. That's tough. I think we just need to realize you need to go somewhere, do the actual setup, and then you'll have seen it.
Thank you very much.
Great. So Julieta Laurino has one question.
Yes, thank you for your talks. I really enjoyed them. So my question is, maybe it's basic, but how do you convince a company to become open source, and where would they take the money from if they don't sell products? I think that's my main question about how to turn all of the companies into open source, and it's difficult.
Yeah,
I guess.
I can give a perspective. I mean, I'm in theory, I'm running a company now that is an open source company. So there's two routes into this. Actually, there's multiple routes, and people have tried to answer this question in multiple ways. So one way is what I'm doing. I'll start with what I'm doing, which is NeuroGEARS is a consultancy company. So that means it's a service company. So that means that all the software we develop is open source and free. But what people pay us for is, as Jakob said, our time to set up, train labs, set up labs, develop new functionality that people need on Bonsai. And to me personally, I like that model, and I'll tell you the disadvantages and difficulties of that model. So this model is actually hard to scale up in terms of like when you want to make something like Facebook that is going to be used like from millions of people, you can't provide like individual support for each one of these users, and you have to find ways of optimizing and separating the consumer from the product. For me, that I like to actually have the personal contact with the people that use the software and that are running the experiments. I like that personal contact. For me, this level of scale works actually quite well. So if that level of scale is the one you care about, that's actually the easy answer is just don't try to be a startup, like to kind of scale up and kind of you can keep yourself small. And that's actually if you're comfortable with that, then that actually works quite well. And I would like actually more companies to realize that this is actually a possibility. You don't have to be a startup. But if you do want to be a startup, then there's like tons of models that people have exploited or explored in the past, where you can have your software open source, but still, because people don't want to put everything together themselves, you can actually provide them. So open source, that's the first thing is open source does not mean non-commercial. All right. Okay. So for example, if I wanted, so I chose to have bonsai open source and free, but actually I could equally have decided to charge for bonsai and still keep it open source, and then people could decide to pay for a distribution of bonsai that I make, or build their own open source. This has actually been a successful model in Linux for a long time. So people pay for, in industry, they pay for people that build Linux configured in the right way for your application, and you get a product that is plug and play and supported. That's the other thing that people charge for, is support contracts for different fields, and that is also has been tried. So yes, you can sell it. It's no, I mean, nowadays Microsoft is they are making like all of their cloud services of Microsoft that power like Microsoft Teams, Outlook, whatever. All of that is running on Linux servers, and everything is open source. Their software stack, not everything, but a lot of it is open source, and they don't care, because what they are charging for is they're renting their computer, their huge computer farm, and you pay like a subscription fee for renting their resources. So that's another model that has become now more prominent, because as a lot of open source software before was powered by advertisement, and now people are moving more towards a subscription model, where you actually have computational resources that are hosted somewhere, and you pay a subscription fee to access them. So that's another model, but there's no definitive answers. I say that's an area where we need more ideas, actually. So if people have more ideas, I mean, that would be great. I would love to discuss them. I've debated some of them for a long time, and would still love to hear more. I still learn more every day. So if Jakob has.
Well, I just wanted to, I agree with everything Gonçalo said. The one point that I would add is that there is this, so first off, I think that we can all agree that spending more money on open source tool chains, tools, developers, organizations in neuroscience is generally a good thing, because we all believe that there's strong arguments that open source tools have advantages in neuroscience. They don't have to be all open source, right? It could be simple things like open interfaces, right? Like no hardware is truly open source. I don't know what's inside the op-amp chip that we're using. That's not open source. The inside of the chips, I don't even know how the capacitors are made. They have some secret sauce that we don't know. I know what a capacitor is. I can use it, right? So by the same vein, I don't need to know how. So for instance, for the Onyx, the magic sauce that gets this data from the head stage to the computer, there's parts there that aren't open source, but we tell people how to use it, so the whole system as a whole can be seen as open source, right? So there's distinctions there too. But the other point is that I think that in all the advantages of open source tools that we described, none of them were really about money or the way that things are reimbursed or funded, right? They're just intrinsically better. And so people often confuse the two and say that open source tools are intrinsically cheaper or something. They don't have to be. You could have a closed source company. So Opencv could have been closed source from the beginning, and we could have had the same price. We could have made it as cheap. We could have been an ethical company without being open source, right? So this is perfectly possible. There are plenty of companies like that. We just also do open source, and the two go together extremely well. But the choice, for instance, of saying we're supporting the company with the pricing that we have that's barely sustainable, but Felipe is really running the OEPS part of Opencv. He's kind of running it as a nonprofit. He's paying his people well, but he's not making any profit on the side, even though it's in Portugal, it's just a company. But we can still do stuff one way or the other, where, for instance, if someone goes to us and says, look, I would like an Ephys system, but we don't have the money. Can you give us one for cheaper? We look at the situation, we go like, well, if you come from MIT, we're going to say, no, we want the money. But if you come from a place where believably you don't have the funding, we'll give you one for the price it costs us to make it or less. You know, like that's independent of it being open source or not. So I think the important distinction is that of being like a mission-driven company and just wanting to be a force of good. And in our case, we want to have people do better science and be like, you know, creative and do interesting stuff. And then we need money to do that. But it's not like we want to make money and we happen to do it by selling scientific tools. And so that's something that there are a lot of companies that used to do that, right? So the reason Opencv, I keep coming back to that example because it's an easy one, Opencv was so much cheaper in the beginning was that a lot of other companies had become a little bit complacent. They had been selling the same stuff they've been selling for probably 5 to 10 years before that without reducing the prices because they're getting paid from grants. That's another weird thing, right? So they're selling a lot of scientific tools to labs that get a startup of like $500,000, $1 million, depending on where you are. And they're like, well, we need an Ephys system. That's how much money we have. So that's not a free market really, right? So they started selling these extremely expensive things. And us coming in as a new company that also happened to be open source, you could be like, well, actually, it doesn't have to be that much. We can make a small profit and undercut you guys severely. So in some sense, what we did was a very capitalist thing. We were just able to take over the market by making the thing cheaper. It happened to be open source, but really it was a force of like, it was kind of a market force at the end of the day. And to be entirely fair, at the time, Opencv was also run by people that were paid to do something else. So we didn't have to pay our salaries at the time, which is something you can't do if you're a PhD student anywhere than the US, right? Because you are on a much tighter schedule. You have n number of years to do something. Josh and I were like, whatever, we can graduate in 8 years, 7 years, who cares, right? These things are all changing. So it was a specific set of circumstances. But I think the ethical part is really important one way or another, right? You can also, as Gonçalo said, be an open source company, and technically you could act non-ethically and just be in it for profit with open source. Can also happen.
Thank you.
Great. We have one question in the chat from Veronica Piatti, who is a researcher from Argentina. She says, thanks for Jakob. Can the new closed loop do electric or optic stimulation? How fast it can be? How much is the weight of the new drive with all together? And can it be used for mice?
Yeah, great question. It very much can. That's the whole point. Is we developed the whole thing for mice. So the whole drive with the new head stage, but the one that I showed you that you can already get is sort of in the same boat. Is under 4 grams, like 3.6 or something. So mice jump with it. So we're writing a methods paper right now where we show that mice move differently with that implant. That has to do with the tether as well. So the full benefit of it will only be available in the new system sometime next year. It's so hard to make hardware right now. We literally cannot get chips to make more. So I can't give any timeline. But yeah, that system is great. It's also not going to be cheap. That's a bunch of cutting edge hardware in there. That's going to be as much as any other commercial system right now. It's going to be partially open source, but it's going to be expensive because it's just extremely high end hardware. One of the things it can do, yeah, electrical and optical stimulation. So John is a goddamn wizard, and he managed to put an electrical stimulator on that little head stage I showed you. So you can do deep brain stimulation without adding extra cables. And there's also an LED driver on there for 2 channels. So you can also do optogenetics all without adding any other hardware. So it's kind of insane that works.
Thanks.
We have one hand raised from Sebastián Stay. We cannot listen to you.
Now, yes?
Yes.
Yes. Okay. Thanks, Gonçalo and Jakob, for your wonderful talk. I want to know your vision about open source tools for the next years. The open source tools can push closed source companies to shift to an open source paradigm. What do you think?
So I'm interpreting this as you were asking whether open source companies can kind of change the models for the closed source companies. Is that the question? So that has started happening quite strongly in a lot of big technology companies. Like, for example, Microsoft. The most recent big example that I know of is Microsoft, where they were basically outcompeted by other companies for the last maybe 10 years. And now their response to that has been to embrace open source because of Linux. So they basically they made a big effort to change their entire software stack server side to use open source technologies. And that was really for them, it was a question of survival. Like they couldn't compete with the reach of Linux in the cloud, and now in the other market that is emerging now in IoT, which is this Internet of Things. You start having these little tiny microcontrollers everywhere, and all of that is not. They're not running Windows. They're running like various versions of Linux or Unix or others, but they are mostly Linux based. And so Microsoft was forced by losing when they lost the phone wars, when they lost the smartphone, they lost that war, and then they started. They were at risk of losing both the IoT war and the cloud war if they had not chosen to adopt Linux. So right now you can open. I mean, the impacts of that are quite profound, even though many people don't realize it. Like nowadays, you can inside your Windows operating system, you can open a Linux shell. Like Ubuntu comes built in. If you go to Control Panel, install Windows subsystem for Linux, you can run a Linux shell on your Windows machine. And I will actually use this as a segue to also answer the question about. This in the chat about whether Bonsai works on cross-platform besides Windows, and that was actually powered by this thing I was telling you about. So Bonsai is built on top of C# and .NET, and in the early days of Bonsai, it was actually a bit tricky to port everything to open source to work on Linux and Mac. Nowadays, because Microsoft has essentially re-implemented the entire .NET stack to work cross-platform on the new .NET 5 and .NET 6. Now it's actually there's no barriers to running Bonsai on a cross-platform system. There's a few things there's work to do on the user interface side of it, but you can run it on Mono. There's instructions. If you look on the forums, the documentation could be improved on that end. But if you go to the Bonsai forums, there are instructions basically telling you how to set it up on Linux. And then one of the goals for next year is to make it the transition to Bonsai 3.0 will be fully built on .NET 5, .NET 6, and will be entirely cross-platform from the ground up. So the story of Microsoft, and in a way also Bonsai, in sense of the fact that Microsoft as a company changed the entire stack to be cross-platform now means that because I'm downstream from that stack, because Bonsai is built on top of that, I'm getting cross-platform support for free in a way because of that change. So in a way, it's great that open source is eating up the world, as they say, is starting to have real impacts everywhere.
Okay, we are past on time, but the discussion is being so great that if Jakob and Gonçalo agrees, we can do two more questions. So there is one in the chat from Ceci Herbert, who is part of the organizing committee of this workshop. She says, Jakob, you mentioned reusing other people's developments. Do you think finding that information can be made easier? Finding that information can be easier? Where should developments live in the interconnecting information?
Yeah, that's a tricky one that we haven't quite figured out. So there's the first problem is just discoverability, and there obviously there's multiple great initiatives of just basically listing projects and making it and making it easier to figure out that someone else had a similar problem, right? So there's like Open Neuro, Open Behavior. We try to do some at Ephys. There's like multiple websites and blogs and lists like that, and I think that helps a lot. I think the one thing that we need more of is that whenever someone in their own lab, like including you guys, solve a little problem with something that's might be useful for someone else, is to just put it out there, because it should be easy enough to find that if someone Googles for something very specific, right? I would like to have a very specific problem, put a very weirdly specific thing into Google, and then I find, oh yeah, so-and-so from that lab that I didn't know has done a similar thing. Let's just ping them. Which brings us to the second problem of like community building, right? And there, I think we're not quite there yet in terms of having like an obvious forum or something like that. Gonçalo and I talked about this like many years ago, of like making like a Stack Exchange type situation or something like that for like solving technical problems. Or like Discourse or something. So that I'm not quite satisfied with that yet. Conferences are obviously good, but yeah, I think it would be good to have something like that. And then the last thing is the logistics for that. And I think for actually sharing stuff, as much as it's just a company, but Git and GitHub particularly are really great, because you can very transparently work on other people's stuff and collaborate, but basically all the infrastructure you need, including solving attribution in some way, although as we discussed, it's not as easy as just attributing. So if you, my sort of immediately actionable thing is, if you do something that generates something that might be useful for someone else, drop it on GitHub and make it discoverable, and then see what happens. Like, it can be something dumb. I have like a lot of small dumb things that I put on GitHub and no one ever uses. But then, you know, for one of two of them, like years later, someone else, like in this case from my own lab, were like, hey, I saw you build a syringe pump or something. And I was like, oh yeah, that thing, that's like terrible. I just laser cut some nonsense. They're like, yeah, but you know, like I changed it. Look, it's decent now. Like, who knows, right? It doesn't cost you to just put the files on there. Just like get the swear words out of the comments and put it online.
Okay. I think that we don't have more questions. I just want to take two ideas that you mentioned, Gonçalo and Jakob. One of them is in regard to the curiosity and the use of programming tools. I think we have, like scientists, as scientists, we have the responsibility to go to schools and to foster the curiosity of children, because they are born curious, but somehow like the curiosity stops, the system, the society stops their curiosity, and maybe we have some work to do there. And the other thing is in regard to the summer schools and workshops. So this course is for Latin American students. We have a really big barrier, which is the funding. Our labs cannot afford those courses, or our salaries. We cannot even think about it. So it is, I mean, many of us that could attend to those courses had the great opportunity of being, of receiving some support, like from IBRO, for example. So it would be great to like improve those fundings for people from our region or other regions that doesn't have a lot of money for courses or scientific related meetings. And well, we are really happy that we have you here in this seminar. I think many of us like really admire you, and we are like really happy. And it would be great to continue working together in some way, like in the future. Maybe we can, I am dreaming in doing some like in place somewhere in Latin America, inviting you to give a talk. That would be great. We have a lot of scientists that could contribute to this thing that Jakob mentioned, like, well, let's show them how an electrode and micro drive is done, or etc. And I think we could work together on that. Okay, so thank you very much of being here. And well, I also thank to the audience for the nice questions that you that should be done.
Yeah, thanks so much. This was great fun. And yeah, of course. And everyone, like, just reach out if you have any questions on the forums, email us. Like, I can speak for Gonçalo on this as well. We wouldn't be doing any of this if we hadn't had help from others or weren't into helping others figure things out. So let's keep the conversation going and, you know, make the community more interactive.
Absolutely, we should definitely continue working together. And your dream, Veronica, is actually completely aligned with the goals of even the Cajal courses. I mean, their whole point was to create courses that could be distributed to local communities, that they could take the materials and run with them and develop them locally. I know that the Opencv course is distributed, the materials are distributed with Creative Commons license. We also discussed actually this a few days ago, and the bonsai course as well is under Creative Commons license. So that's the goal. So that absolutely there should be no barriers for this, stopping this. So no, thanks for organizing. This is great.
Great.
And,
thank you very much. See you soon.
See you.
Goodbye.